Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about terminal velocity. So, we need to discuss what happens to the forces when a skydiver falls through the air. So let's say you're a skydiver, you're falling through the air. Let's label the forces acting upon you. So initially at the start, this is you, yeah? Initially at the start, the only thing acting on you is your weight pulling you down. So W stands for weight. So W equals the weight. But as you fall through the air, what happens is air resistance starts to build up. Think about it, as you're falling through the air resistance will start to build up. So let's draw a small arrow to indicate here the air resistance. We can clearly see right now the weight is greater than the air resistance, therefore it's still increasing in speed. So yes, you're going to be falling through the air, increasing in speed. So weight is greater than air resistance here. Now, as you continue to fall, this won't happen forever. What happens is the air resistance will increase so that it balances out your weight. So the air resistance and weight will balance out each other. Let's put that down then. So the air resistance, look at the length of the arrow. The air resistance will be equal to the weight. So from the top, initially at the start, the weight is acting only. As you fall through the air resistance starts to build up. Eventually, the air resistance balances out the weight. Therefore, when the forces are balanced, will it increase in speed? No. So, now air resistance is equal to the weight. There is no acceleration. So you will no longer increase in speed. So up to that point, you were increasing in speed. But now, when the forces balance out, you stop increasing in speed. So there's no acceleration and you reach a maximum velocity. This is called the terminal velocity. So the velocity you reach here, that will be the terminal velocity. So we reach a maximum velocity. And this is called the terminal velocity. Think about the word terminal, it means the end, it means the final. So that's the reason why. So terminal velocity. So from the top, you start to fall down, the air resistance starts to build up. Eventually, when they both balance out, the acceleration stops and you move at a terminal velocity. That's always when you fall through a fluid. Right, okay, so what happens when you open the parachute? So those three steps still apply, so we had those three steps, but now what happens is when I open the parachute, so initially notice we still have the air resistance balancing out the weight, there's no acceleration and we're moving at a terminal velocity. But now, as we fall down and we open up a parachute, what happens is the air resistance increases dramatically. So look, we can clearly see that which one is bigger? The air resistance is much greater than the weight. So what does that mean when the air resistance is much greater than the weight? It means that the object will start to decelerate. So the object will decelerate. So deceleration. So it starts to slow down, so your speed will decrease. My speed will decrease. That won't happen forever, yeah? What happens is the forces balance out again to reach a lower terminal velocity. So eventually the air resistance upwards over here will be equal to the weight going down again. So once again, we have air resistance equals to the weight, and we reach a lower terminal velocity. Yeah? Okay, so from the top there's 6 stages here. It's quite a lot. So at the start, going up to the top, we're falling through the air resistance builds up, eventually they balance out, and I reach a terminal velocity. Then, if I open up the parachute, the air resistance increases dramatically, therefore I start to decelerate. But eventually the forces balance out once again, and therefore I reach a lower terminal velocity. So, what does that look like on a graph? Well, let's look at it. If we have the following stages now, so I've just summarized it. I've just drawn dots here to represent the skydiver 1, 2, 3, 4, 5. Notice initially the weight is only acting, then the air resistance builds up, then finally the air resistance matches the weight. Then I open the parachute, so this point here is parachute being open, so parachute opened here. This bit is obviously terminal velocity. The reason why the parachute, not the parachute, the forces are balanced. And then last of all, once again, it's another terminal velocity here. Terminal velocity. But this is a lower, so this is definitely lower, which is safer for you to make that landing. Okay, so let's try and sketch the graph. Okay, so what will the graph look like? So first of all, the velocity will increase and then plateau off. Why? Because this is when it reaches terminal velocity. The forces become balanced, the velocity no longer increases. When I open up the parachute, my velocity will drop down because I'm going to decelerate. That's going to be when I open up the parachute, but eventually I will then reach a lower terminal velocity before I go back down again. And that's our graph for the terminal velocity. So let's label different points. Point number 1 is there, number 2 is there, stage 2. Stage 3, balanced forces, at terminal velocity, it's over here. Stage 4, when I'm decelerating, it's over there. And 5, lower terminal velocity, is over here. Make sure you can match them up. You understand the reason why I've matched those parts of the journey to these stages of the graph. Okay everyone, let's summarize the lesson. So, summary. When a skydiver falls through the air, the forces acting upon him change. Yeah, so they change. Obviously they're not the same throughout the whole journey. Initially the only force acting on them is the weight. As the skydiver falls down, the air resistance starts to increase. The air resistance builds up and eventually it balances out the weight. Yeah, balances out the weight. Therefore it moves at a terminal velocity. So the skydiver moves at a constant velocity, which is called a terminal velocity. When the parachute is opened, the air resistance increases dramatically. So when you open up the parachute, the air resistance will increase dramatically, and therefore the skydiver will decelerate. The velocity will reduce. Eventually, once again, the air resistance will balance out the weight, but you will move at a lower terminal velocity. So yes, they balance out again, but now you're moving at a lower terminal velocity. And we have our wonderful graph, which summarizes the learning here. And that's it for another session. I shall see you next time. Goodbye.